Today's critique examines a highly detailed reference manuscript, breaking down the complete architecture, cellular mechanics, and electrochemical signaling pathways of the human nervous system. Reorganizing the content into a cohesive, linear progression from the macrosystematic level down to the microcellular level will eliminate the current structural redundancies.
Yeah, because reading through this material as it currently stands is, well, it's a bit like interacting with a digital map where the zoom function is heavily glitching.
Oh, for sure.
We are rapidly hurtling from a satellite view of an entire country, plunging all the way down to a street-level view of a single driveway, and then suddenly snapping violently back out to the state level. It really leaves the reader feeling entirely unmoored.
Right, because the current arrangement forces the text to just circle back on itself constantly. In the first half, the author dives straight into cellular architecture, giving us these highly granular breakdowns of glial cells and then pushes right into action potentials.
And then suddenly we jump to the reflex arc.
Exactly. But then, almost as if the author forgot what they wrote and started a brand new document, the second half reintroduces the broad central versus peripheral nervous system division.
Yeah.
We get the cellular architecture repeated, and synaptic transmission is explained all over again.
Which creates an incredibly dizzying experience. The reader is forced to process the exact same concepts in these fragmented, disconnected pieces.
Right.
And when you present an audience with material this dense, where they need to understand everything from, macroanatomy down to the ion channels, you cannot afford to make them spend cognitive energy trying to figure out where they are in the physical body.
I initially wondered actually if the author was attempting some sort of spiral learning technique here. Introducing concepts lightly and then returning to them with more depth later on.
Oh, I see what you mean.
But looking closely, that isn't what is happening. The text isn't deepening the knowledge on the second pass. It is literally repeating the foundational definitions.
Which just stalls the momentum completely. So to solve this, the entire text needs to be restructured into a single unified narrative arc, utilizing a strict top-down approach.
Okay.
The material must move systematically from the macroanatomy down to the microscopic mechanisms without ever doubling back. The goal is to guide the reader from the most visible, tangible biological structures down to the invisible molecular engines.
Let me test that approach. If I'm restructuring this, I would begin the piece exclusively with the broad structural organization. The stark division of the central nervous system and the peripheral nervous system.
Yes, exactly.
Establish immediately that the CNS is the brain and spinal cord, and the PNS is the vast network connecting it to the rest of the body. Once those borders are drawn, I zoom in exactly one level to the hierarchy of the brain. The forebrain, midbrain, and hindbrain. And the spinal cord. I don't mention a single cell yet.
Right. Keeping the camera pulled back like that is crucial. By establishing those macro structures first, you build the physical stage. Only when the anatomy is fully mapped do you transition smoothly into the microscopic level, specifically the cellular architecture section.
Makes sense.
This is where the author can merge all those repetitive points about astrocytes, oligodendroid cells, and Schwann cells into one definitive, heavy-hitting section.
Kind of putting all the cellular actors on the stage at the exact same time.
Yeah, rather than introducing an oligodendrite in Chapter 1 and a Schwann cell in Chapter 4, you introduce them together. You explain that astrocytes form the blood-brain barrier in the CNS, while oligodendrites myelinate the CNS, and Schwann cells do the equivalent job out in the PNS.
Oh, I see. And because the reader already understands the difference between the CNS and PNS from your opening chapters, they instantly understand the geographic distribution of these cells.
Exactly.
Then, following that top-down logic, you conclude the document with the action potential and synaptic transmission. By placing the pure electrochemical signaling at the very end, it stops being a random interruption and instead acts as the molecular engine powering the massive anatomical system you just spent pages building.
Right. By stabilizing that map, country, state, city, street, house, the reader never has to pause and mentally calculate where a Schwann cell lives relative to a cerebral hemisphere. They can just absorb the underlying biology.
Directly linking the microscopic electrochemical properties to the macroscopic survival behaviors described later in the text will ground abstract anatomical definitions in tangible physiological consequences.
Because the descriptions of cellular mechanics in the current draft are highly abstract. They read as extremely clinical.
Yeah, very much so.
The author gives us the resting state of negative 70 millivolts, the voltage-gated ion channels, and saltatory conduction, but discusses them as if they exist in a vacuum, completely disconnected from the visceral survival behaviors mentioned in passing elsewhere in the manuscript.
I see what you're going for by wanting to connect the micro to the macro, but let me play devil's advocate here for a second.
Sure.
Is there a risk that dwelling on complex macroscopic behaviors, like the fight or flight outcomes, might distract from the purely structural and electrical focus the author clearly intended to highlight? I mean, this is a biophysics and anatomy text, after all.
It is a valid concern, definitely, but I would argue that function illuminates form.
How so?
Well, when a text tells a reader that an action potential is a transient reversal of the membrane electrical potential, where sodium channels open, sodium rushes in, and potassium rushes out, it provides pure, unadulterated biophysics.
Right, it's very accurate.
It is entirely accurate, yet entirely sterile. The reader is left memorizing a sequence of microscopic ions without understanding that this specific sequence is the literal difference between life and death for an organism.
Oh, I see. It becomes a rote memorization task rather than a biological narrative.
Exactly. We need to introduce functional stakes. The author can use the macro survival mechanisms already present in the text to demonstrate why the microcellular mechanisms matter.
Right.
Bridging the gap between pure anatomy and practical physiology ensures the reader internalizes the mechanics. If we want an audience to deeply understand how a voltage-gated sodium channel works, we have to show them what happens to the whole organism when it fires perfectly, and what disaster occurs when it doesn't.
Let me attempt to build a bridge for one of these concepts. The text talks extensively about the myelin sheath and saltatory conduction. The mechanism itself is fascinating.
It really is.
The author accurately explains that the action potential essentially jumps across the exposed sections of the axon, which are the nodes of Ranvier, to drastically increase the velocity of the transmission.
But the author stops there. They state the velocity increases, but they never anchor that speed to a consequence. And interestingly, a few pages later, the author has a fantastic section explaining the reflex arc, how a sensory receptor detects a stimulus, sends an afferent signal to the spinal cord, and an interneuron immediately relays a command back out via an efferent motor neuron to an effector muscle.
And those two concepts, saltatory conduction and the reflex arc, are treated as completely separate phenomena, happening in different universes.
Which is such a missed opportunity. Instead of just coldly stating that saltatory conduction drastically accelerates transmission velocity, the author needs to tie this electrical concept directly to the reflex arc, show the reader the actual physical stakes.
Okay, so picture a hand accidentally brushing against a searing hot stove. The sensory neuron fires.
Right.
If that signal had to travel down an unmyelinated axon as a continuous wave of depolarization, meaning it had to physically open every single sodium channel along the entire length of the arm, it would be biologically too slow. The tissue of the hand would burn severely before the signal ever reached the spinal cord to trigger a reaction.
But because of those oligodendrocytes and Schwann cells we organized earlier, which wrap the axon in myelin tape, the electrical signal gets to skip massive lengths of the axon.
Wow, yeah.
It jumps purely from one node of Ranvier to the next. The host organism is saved from a severe burn solely because of a microcellular adaptation.
So the text needs to explicitly illustrate that without this exact action potential jumping across the nodes, the efferent motor neuron could never prompt the effector muscle to pull away from the stimulus before the cerebrum consciously registers the pain. The burn happens if the myelin isn't there.
Exactly. By anchoring the microscopic physics of saltatory conduction to the macroscopic, visceral reality of a burn reflex, the abstract numbers and ion names suddenly carry immense weight.
That makes total sense.
You aren't just memorizing a textbook definition that myelin speeds things up. You are fundamentally understanding how a biological adaptation solves a physics problem in time to save the organism. It transforms a clinical definition into a dramatic biological imperative.
Reframing the densely packed brain hierarchy section around functional pathways rather than isolated geographical bullet points will create a far more digestible reading pace.
Grounding the text in functional reality absolutely helps with engagement, but the sheer volume of data the reader is asked to absorb is still overwhelming.
Oh, especially when navigating the dense geography of the central nervous system.
Yeah, the breakdown of the brain, the forebrain, midbrain, and hindbrain, currently reads like a rapid-fire inventory list.
It reads a bit like an alphabetical phone directory of brain parts, presenting the cerebrum, the diencephalon, the cerebellum, the pons, and the medulla oblongata as isolated dictionary definitions creates a heavy bottleneck of memorization that abruptly halts the reader's momentum.
Right.
It feels like standing in a massive warehouse where someone is just pointing at boxes on a shelf and reading off the labels. Here is the parietal lobe. Here is the thalamus. Here is the pons.
And the reader is left desperately trying to juggle all these disconnected boxes at once. It is exhausting. To fix this, the author needs to shift the focus from a purely regional catalog to a continuous biological relay. These brain areas must be grouped by how they actually communicate with one another to execute a specific physiological task.
So what we really want is the organizational chart of a biological company, showing who reports to whom and how the information actually flows through the neural office. Let's trace one of those pathways based on the current text.
Okay, let's do it.
Right. Now, the author lists the hypothalamus in the forebrain section as the master regulator of homeostasis, controlling body temperature, hunger, thirst. Then, many paragraphs later, completely segregated in the hindbrain section, the text lists the medulla oblongata as the manager of heart rate, blood pressure, and respiration.
And the connection between those two vital centers is never fully established. They are treated as entirely independent organs. But biological systems do not operate in isolation.
Right.
Instead of simply listing the hypothalamus and then later listing the medulla oblongata, the text should illustrate a sequence. It needs to tell the story of a pathway.
So imagine the organism is suddenly thrust into a highly stressful situation, say a massive drop in blood pressure or a sudden need to sprint.
Yeah.
The hypothalamus, sitting up in the diencephalon, is constantly tasting the blood, monitoring the internal environment. It senses a massive shift in homeostasis. The body needs more oxygen to the muscles immediately.
And so the hypothalamus acts as the executive director. It doesn't pump the heart itself. Instead, it drafts a complex chemical and electrical memo and sends that signal down through the midbrain bridge straight into the medulla oblongata in the hindbrain.
And the medulla oblongata receives that top-down command and acts as the factory floor manager. It physically executes the physiological adjustment, drastically increasing the respiration rate and spiking the heart rate.
Yes, by grouping these structures by their pathway, the executive sensing the need in the forebrain and the manager executing the physical response in the hindbrain, you drastically ease the cognitive load on the reader.
Exactly.
They are no longer memorizing two disconnected facts on different pages. They are following a logical, causal chain of events.
I can anticipate a structural pushback here, though. Some might argue that organizing the text by pathway makes it significantly harder to use as a quick reference tool. If someone just wants to know where the thalamus is located geographically, a purely structural list is much easier to scan.
I mean, that is a fair point if this were purely a geographical atlas. But this manuscript aims to explain the architecture alongside the electrochemical signaling. It is trying to explain the life of the system.
So you're saying we can do both?
We can absolutely blend the two goals. The author can maintain the clear geographical headings, forebrain, midbrain, hindbrain. But within those sections, whenever a new structure is introduced, its function should immediately be tied to the structures previously discussed.
You build a web, not a list.
Exactly.
So when the text reaches the pons in the hindbrain, it shouldn't just state that it assists in autonomic functions. It needs to describe how it acts as the critical relay station, physically routing the higher-level motor commands from the cerebrum down into the fine-tuning processing centers of the cerebellum.
Which fundamentally changes the pacing of the entire read. Instead of stalling out against a massive wall of disjointed anatomical facts, the reader is carried forward by the momentum of biological action and reaction.
Right.
It shifts the experience from forced rote memorization to genuine systemic comprehension. The reader is watching the nervous system operate in real time.
Let's review the main takeaways from today's critique.
We covered 3 core areas of feedback designed to maximize the impact of this highly detailed reference material. First, we addressed reorganizing the macro to microstructure to eliminate structural redundancies.
Yep.
Second, we examined tying cellular mechanics directly to macroscopic survival mechanisms to highlight their relevance. And finally, we discussed pacing the dense brain anatomy section by demonstrating functional pathways rather than isolated lists.
Right, so for actionable takeaways, the author should merge all the redundant sections into a single top-down narrative. Start broadly with the central and peripheral systems, move into the brain regions, detail the cellular players, and end with synaptic transmission as the ultimate engine.
And for the relevance piece?
Second, use the visceral reality of the reflex arc as a practical anchor to explain abstract electrical concepts, showing how saltatory conduction physically prevents a severe burn.
Love that.
And finally, map out the physiological connections between brain regions, like demonstrating the command chain from the hypothalamus down to the medulla rather than listing them in a geographic vacuum.
We highly encourage the author to apply these structural and pacing adjustments and submit the revised work back in for another critique. Because at the end of the day, an architectural blueprint of a skyscraper shouldn't just show you where the wires are located in the walls. A truly masterful blueprint helps you understand exactly how the electricity flowing through those wires brings the entire building to life.